We are going through this paper today, the 4th July one. So please take it out. Okay, the first one, 5A, part 1. Answer is 2 square times 3 times 7. Okay, please self-mark, do your corrections. I believe there is no need for me to go through this one. Now part 2. Answer n equals to 72. Anybody needs me to go through? Anybody? If yes, please raise your hand. Part B. Number of elements in A union B is 11. Okay, A union B, there should be 11. Anybody needs help for this? Then the next part, the elements are 16, 14, 2, 8, yes? Do you know why? Okay, now for anybody managed to get this answer first? Anybody? Raise your hand. Okay, since nobody got it, I want to let you know that we need to make a small change to the question. No, even if there is no mistake to it, you can still solve it. Okay, so but I just want you to do this. A intersect B prime intersect C prime equals to open bracket instead of a 1. So it is open bracket 2, 6, 14, 18. This will allow us to do the subsequent question. Okay? Change it to this question first. Then let me just fill up what we have in the Venn diagram first. A, B. So in A, your x is an even number. So we have 2, 4, 6, 8, 10 happens to be in the middle. Then 12, 14, 16. Okay, and on the other side, we have x being a multiple of 5. So we have 5 and 15. And we notice that 10 is actually found in both set A and set B. So the rest are not found inside A and B, they will be found outside. And we have 1, 3, 7, 9, 11, 13, 17. Oh, you mean there's another 18, right? Okay, let me just put it here, 18. Okay? So far, this is what we have for set A and set B. Then now they introduce something, another set, it is set C. So the clue that they gave us is that set C has all these elements inside. Okay? So I am going to now draw your A intersect B complement intersect C complement. Right. We are now going to break down this portion into, because we do it from left to right, correct? So we are trying to find out A intersect B complement, which then intersects C complement. Okay, I'm going to find out what this looks like on my Venn diagram first. So this is A, this is B, and I have one more set, C over here. So C complement, what does it look like? So in red color, I'm going to shade C complement. So that is everything except for C. Okay, in red color, C complement. Then now, I also need one more, which is A intersect B complement. Okay, let's see where this A intersect B complement is. Okay, I'll just quickly sketch at the side. It's A, B. A, I will shade A. This is my A. And then B complement. I'm going to shade B complement with another color. Let's use orange. B complement with orange over here. So where is my A intersect B complement? It will be this region, right, where they intersect. This one that I'm highlighting in yellow will be my A intersect B complement. A intersect B complement. Okay, so far. So in the original question, they say A intersect B complement intersect C complement. That means I want the intersection point of this highlighted yellow color region with my red color lines. Okay, so I'm going to superimpose my yellow color over to show you what A intersect B complement looks like. Okay, the same yellow color is brought over. So now can you tell me what does A intersect B complement intersect C complement look like? Which region are we talking about? Is it only the yellow color part? Or is it the red color part? Or is it the yellow intersect red color part? Yellow intersect red color. So the yellow intersect red color is my A intersect B complement intersect C complement. Okay? So I am now going to remove all these lines. I am just going to highlight in another color, green color, what my A intersect B complement intersect C complement looks like. So this is the region. Yeah, to show you the difference. Okay, so green color will be my A intersect B complement intersect C complement. Okay, and what is found inside here? 12. Sorry, not 12, 2. Yeah. What I have inside here will be 2. And what else did they say? 2, 6, 14, 18. Okay? Then in the middle over here, we still have our 10, we still have our 5 and 15. And we still have all the numbers out here, 1, 3, 7, 9, 11, 13, 17. And now we can see what falls inside C. So we have 4. Oh, sorry, this is 18. 4, 8, what else? 10 is already inside between A and B. What else do we have? 12. And 16. Okay? So the answer for this question will be this is part of the question. This is so the answer for part 2, part A is elements are 4, 8, 12, and 16. Okay? So now, can we describe set C in words? C is where X is, what do you think? Yeah, multiple of 4. Okay? So initially, even if you had seen the question as 12, 6, 14, 18, you can still do it. But it's just that you can't describe set C in words. Okay? But after I've changed the question, now you can. Alright? Can I continue? Question C. By drawing a Venn diagram, because in this case we have 28 attending piano lessons, 17 attending flute, 12 attending neither. If you add them all up, you realize that it is more than 50. So what that tells you is that there will be an intersecting region. Okay, if I draw a Venn diagram where I have piano and flute, students learning piano, students learning flute. Some students will be learning both, and they are going to fall in the middle. Then I can say that the number of elements in learning piano only, let's just let it be x, and then number of elements over here in the intersection will be y, and the number of elements in z, let it be z, number of elements inside learning flute only. Then I can form equations. What is the value of x plus y? What's the value of x plus y? 28. That's the number of students learning piano. What about y plus z? Winston, how much is y plus z? $17. And finally, x plus y plus z equals to? How many? We don't know yet, right? We have 12 over here. Okay? So what is x plus y plus z? Because 12 of them don't study anything. That must be 50 minus 12. That will be 38. Okay? Anybody lost? We have 50 students. 12 are not learning anything. So they fall outside P and F. Then they want the number of students who only attend piano lesson. That means they want the value of x. With these three equations, you can solve for x. You realize that x is actually equals to 21. Okay? Modulus? Why modulus? Oh, why? Uh-huh. So what will your working be like? But what's the logic behind this? Uh-huh. Oh, okay. So you're saying that in the middle will be 7 lah. Okay, then you will take 28 minus 7. Yeah, oh, okay, also can. Okay, so there are more ways to do this than just my way. Next one is question 6a. The missing value will be negative 8.5. Then plot the graph out yourself. You will find that the gradient is approximately 4.5. As long as your diagram is drawn correctly, the range that we accept for the gradient can be quite wide. Okay, so don't worry about it. As long as you draw a decent tangent line, then you calculate your gradient correctly, we will give you the mark. Then for part 4, by drawing a suitable line on your graph, find the solution to the equation blah 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 blah. Okay, so how we do this will be, we state what is the equation, the solution that they want us to find. 2x cubed minus 3x squared plus 4 equals to 0. Now we do not have this equation in our graph. Rather, what we do have is, y equals to 2x cubed minus 3x squared plus 5. Okay? our goal is to change this to look like what I have in red. Okay, so this is the approach to do it. I want to change the question given in green color to look like what I have in red. So what do you propose I can do to make it look like the one in red? I can plus what? I plus 1 on both sides. What will happen if I plus 1 on both sides? I will get 2x cubed minus 3x squared plus 5 equals to 1, correct? This is the original question in green color given in the question, but we only have the graph for the red color equation. So if I add 1 to both sides, I will end up with this. And this region, this part, is actually what I have plotted out earlier on. And I say that this yellow, this highlighted in yellow color, is the graph of y equals to blah 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 blah. Okay? So now y is equals to this in purple color. In other words, y is also equals to 1. Since y is equals to 1, I need to draw my graph of y equals to 1. So initially we had a curve already, looking something like this. Y and x. This is the graph of, in red color, y equals to 2x cubed minus 3x squared plus 5. Then I am going to introduce another graph, a horizontal line of y equals to 1. Such that when they intersect, my straight line of y equals to 1 and this curve, when they intersect, I will find the solution. Okay? Now how does this actually work? If I ask you to solve these two equations simultaneously, just extra knowledge for you. If I ask you to solve these two equations simultaneously, this is what you are going to do. Y equals to 2x cubed minus 3x squared plus 5, and the other one is y equals to 1. Call this equation number 1, call this equation number 2. Solve them, we will end up with 2x cubed minus 3x squared plus 5 equals to 1. Therefore, 2x cubed minus 3x squared plus 4 equals to 0. Isn't this what was highlighted in green? That's what they wanted you to find, the solutions to this. And the solutions to this is actually a simultaneous equation, finding the point of intersection between your straight line and your curve. Okay, so that's how we conclude that drawing a straight line of a horizontal line of y equals to 1 will help us solve for this equation in green. Yes, Brian? Say again? Why negative 1? Derive the green one from the red one. So if you were to draw the line of y equals to negative 1, you go and solve it simultaneously, what will you get? Let's see. So what Brian is suggesting is, let us draw the line of y equals to negative 1, and then you have another equation that is from your curve, right? Y equals to 2x cubed minus 3x squared plus 5. Correct? These are the two equations you have. If you solve them simultaneously, what are you going to get? Then you will have 2x cubed minus 3x squared plus 5 equals to negative 1. That means 2x cubed minus 3x squared plus 6 equals to 0. If you draw the line of y equals to negative 1, then you find intersection point, you are finding the solution to this equation, which is not what the question wants. So you have done it the other way around. Okay? Do you see why this doesn't work, Brian? Okay, if you need more clarifications, come and see me later. Otherwise, I'll move on to the next question. Part A, solving, you will get x equals to -4. Part B, x equals to 1.5, y equals to -3. Okay? You get it correct again? You're not even on that page.
Yeah, correct.
Part C, 10p minus 29 over p plus 2, 2p minus 3. It is okay if you expanded your denominator, it is fine. Nope. No. No, because I took out the plug. Okay, part D, this is the answer. A part 1. Okay, now we are given two triangles AEC. Our standard approach, we draw the two triangles AEC. Since we want to show that they are congruent, we draw them in the same orientation. This will be FBE. What is the approach that you use to show that they are congruent? Which test did you all try? Any more besides RHS? Okay then, where is my right angle triangle? Where is my right angle? Okay, AEC and FBE. So that is the first one I can write down. Angle AEC equals to angle FBE equals to 90 degrees. Why? Reason is angles in a semicircle. Okay, we have proven the right angle inside the right angle triangle. To use your RHS test, what else do you require? What else do you require for your RHS test? Hypotenuse. Okay, where is the hypotenuse? Must be AC lah, and FE. So that is what we are trying to prove next. AC, is it equals to FE? Yes, and why do we say so? Yeah, both of them are diameters of two circles with same radius. Okay, and this is our hypo. This is our right angle, and then we have our hypotenuse ready. So we are left with just one last side. Can be any side. So do you want to prove AE equals to FB or EC equals to BE? Hello, that's the hypotenuse. We've proven that already. EC equals to BE, okay? That's what he's trying to prove. EC. And what's the reason? Yes, they are both radius of a circle. With same radius. So by your RHS test, triangle AEC and triangle FBE are congruent. A lot to write, you need to write it. No short form for triangle, no short form for the word congruent. Then part 2, another triangle that is congruent, BFD. We can use the same test to prove that they are the same. Next up, we have part 3. Why is EB parallel to DF? what are the rules? What can we use to prove that two lines are parallel? We've done one of this in TYS before. Magnitude? Anybody? How do we show that two lines are parallel? What are some properties of angles for parallel lines that you know? Okay, yes, Ryan has said we know our alternate angles. They are equal, right? So alternate angles, parallel lines. Okay, those are equal. What else do we know? Huh? Corresponding parallel lines. What else do we have with the right hand side parallel lines one? Only these two? You remember your F, U, Z, O that Mr. Tan taught you? F, this is your corresponding angles, right? Then the Z over here will be your alternate angles. What about this U? What is it trying to say? Interior angles. Interior angles, parallel lines. Okay, so we can call these your theorems. You can call this your alternate angle theorem, your corresponding angle theorem, your interior angle theorem. So instead of using it this way, we go backwards. As long as I find a pair of alternate angles and they are the same, then I say that those two lines are parallel. As long as I find corresponding angles are the same, I say that, hey, you have a pair of parallel lines. As long as I show that interior angles, they sum up to be 180 degrees, I also can conclude that there is a pair of parallel lines. So what are the angles that we're interested in over here? We want BE and the line DF. So I think I can consider these two angles. What do you think I should prove for this? We have shown that this is actually a 90 degree, right? Over here 90 degrees. And over here also 90 degrees because they are angles in a semicircle. So what do you think I should try to prove? Interior, alternate, or corresponding? Interior. What is it that I need to show then? Yeah, I need to show that they both add up to be 180 degrees. Once I have shown that, then I can conclude. Okay, so working presentation will look like this. Angle EBF equals to angle DFB, which is 90 degrees. They are angles in a semicircle. Okay, so since both of them are 90 degrees, since angle EBF plus angle DFB equals to 180 degrees, by interior angle theorem, EB is parallel to DF. Okay, it is working backwards. Yes? What is your longer way? Alternate angles from where? Two isosceles triangles. Okay. Oh. Okay. So because these are vertically opposite angles, then this is isosceles, this is isosceles, then this angle must be the same as this angle. So you use alternate angle to show that this is parallel to this. Yeah, also can. So that's his method, which works also. I hope you are doing your corrections if you didn't get it correct. Then B, part 1. Calculate the area of triangle POQ. Okay, area equals to half times 4 times 4 sine 130 degrees. That will be 6.1283, approximately 6.13 square centimeters. Then part 2, calculate the area of major segment, which is shown unshaded. So basically, I need to find the area of the whole POQ. Okay, that segment. Then I add the area that I got in part 1. So area of POQ will be equals to 360 degrees minus 130 degrees divided by 360 degrees. Okay, that is the ratio, the proportion that is not shaded, times the area of the whole circle, pi times 4 square. So this gives me 32.114 square centimeters. I do not want to round it off yet. So the total unshaded is equals to 32.114 plus 6.1283, get 38.242, which is approximately 38.2 square centimeters. It's okay, got it correct? Okay. Part 9a. 320 over x kilometers per hour. That's the speed, average speed. Then part B, who needs help to show the equation? All managed to get it? Brian, do you manage to get it? No. Okay. Average speed of the car. Is equals to 320 divided by the time taken. How much is the time taken by the car? X plus 2.5, but I don't like my decimals in my fraction, so I will write it as 5 over 2. But I also don't like fraction in my fraction, so I'm going to multiply the top by 2, multiply the bottom by 2. Then I'll get 640 over 2x plus 5. Okay, they are the same. Then the speed of the car is 80 kilometers per hour lower than the train. So then 640 over 2x plus 5 plus 80 equals to the speed of the train, which is 320 over x. This is the equation that you need to form. Then just manipulate, you will get it. Did you start with this equation? You have 2x squared plus 5x minus 20 equals to 0 and shown. Then in part C, solving equation, just asking you to solve, you give me the two answers, 2.15 or negative 4.65. You get it? So part D. In part C, we're only solving for x. So how do I present my answer for the beginning of part D? I will state both of them first. X equals to 2.15 or x equals to negative 4.65. Then I'll reject this. This is my first step for my presentation for part D. Then the car speed will then be 640 over 2x, which is 2.15036 plus 5. Get an answer. Round it off to 69 kilometers per hour. Okay, now for question 10, we're given a triangle with two angles and a side. Do you know that just by looking at a question, just by looking at a diagram, what is given to you, you can already determine which rule to use? You can determine whether it is a sine rule or cosine rule. Okay, as long as you have two angles given to you and one side, you use your sine rule. As long as you have one angle that is not included and you're given two sides, use your sine rule. Anything else, just use your cosine rule. Okay, so in this case, I have two angles and one side. I know I'm going to use my sine rule. The sides that I'm interested in will be BC, and over here BC minus 5, 65 degrees and 45 degrees. Forming an equation, using our sine rule, we will have BC over sine 65 degrees is equals to BC minus 5 over sine 45 degrees. Then just make BC the subject. Do your multiplication. We have BC sine 45 degrees equals to BC minus 5 times sine 65 degrees. We may expand the right hand side. And group the like terms together. BC will then be 5 sine 65 degrees over sine 65 degrees minus sine 45 degrees. Then part 2 is just pressing your calculator. Since you have all these values already, they are all numbers, you can just punch them inside. You get 22.748, which is approximately 22.7 cm. Yes? Oh, I skip a step. From here to here, right? I skip a step, you will be able to figure it out yourself. Okay, can I move on already? Who still needs more time? Okay, last question. Cosine, okay, this one answer is negative 11 over 40 for part 1. And part 2, we also have 11, no, sorry, not also, we have 11 over 40. Okay, do you all get it? Anybody needs me to go through? Otherwise, I think this is quite basic. Then we are done with this. If you are done with your corrections, please pass them to the front.